Hello, everybody. Next, I will show our group's project. First, I will show the outlines, and then my partners will show you more detailed information. Firstly, we divide the whole task in 4 small parts. We predict the stock's price first, and then we evaluate our prediction and derive the risk of our method. By considering the risk and the expected return, we can select stocks from the whole universe and structure our portfolio. At last, we will summarize our information and make the conclusion. This is our formal model. Theta is the market information, S is the stocks information, chi is the residues of our model. We evaluate our risk by considering chi. And then is our return. If we structure a portfolio with weight WI, then our whole return looks like there. And our whole risk looks like here. So COBIG is the covariance matrix. First, we try linear model, and the factor we simply use from a branch 5 factors. The beta here is a linear coefficient changing with time. But this don't give us a good result. So we try to focus more on S instead of theta. For example, we used return time series as this S. And we find that this form is really suitable for RNN, that's recurrent neural network. And in fact, if we want to change our model, we let in a forget atom, and the formula is the LSTM model.
And before talking about the model, we'll briefly introduce why we are using deep learning method. In recent years, we saw a ton of development in deep learning by gathering knowledge from experiments. This approach avoids the need for human operators to formally specify all the action from massive stats that the computer needs. The convolution on the right-hand side is an example of convolution network that exactly tells whether this is a cat or dog in the picture. The following is some guess at why we are using deep learning instead of conventional approach for predicting the data. In fact, it is somehow conceptually impossible to come up with a complete axiomatic system that fulfill our needs in mathematical and statistical fields. In short, given the Zimmer-Frank set theory and historically controversial axiom of choice included, this may suggest that the analytical approach is problematic, i.e. building sophisticated models like what we have, a statistical model or a partial differential equation model. So instead of improving our analytic skill, maybe we can find some interesting results empirically. And on the right-hand side is one of my favorite philosopher and mathematician freak, whose main contribution is the book Foundation of Mathematics. So the achievement of LSTM. LSTM are well suited to classifying, processing, and making predictions based on time series data. Since there can be time lags of unknown duration between important events in the time series, LSTM were developed to deal with the vanishing gradient problem that can be encountered when training traditional RNNs. LSTM has been applied in many areas, not only in finance sector, but also in other sectors like epidemiology as well. The best prediction of COVID-19 given by LSTM outperformed the SIR delayed model and some canonical statistical model with thousands of parameters. Before talking about long short-term memory, the so-called LSTM developed from RNN, we would like briefly review why use our recurrent neural network and what is difference between shallow neural network. In principle, when using shallow neural network, almost any input data, image, time series, for example, can be flattened and concatenated into a vector in RD. However, by doing so, we fail to capture the structural information beneath in our data, and there is no canonical meaning in flattening it. So some architecture are developed for image and time series application. convolutional neural network, and a recurrent neural network, respectively. And in the next part, my teammates will show the structure of ASTM.
Theoretically, recurrent networks can use their feedback connections to store representations of recent input events in the form of activation. However, the process is too long, and the error signals flowing back in time tend to firstly blow up or vanish. The case 1 may lead to oscillating weights. In case 2, long time lags do not work at all. So LSTM is designed to overcome these error backflow problems. To make sure that the error flow is constant, LSTM introduced some additional features. An input gate unit is introduced to protect the memory content stored in unit J from perturbation by irrelevant inputs. And the output gate unit is introduced to protect other units from perturbation by currently irrelevant memory content stored in unit J. The resulting unit is called a memory cell. The graph on this page shows the performance of LSTM for some stocks. We can see that the performance is relatively good. Next, I'll pass XIAORONG to introduce how we evaluate the risk.
The next step is stock selection. We select the 10 stocks with the best performance based on Sharpe ratio to construct our final portfolio. RS is the return we predicted. RF is the return of 1 year US Treasury bills. Then we need to find sigma S. Firstly, we calculate the residuals of each stock, which is equal to the return we predicted minus the actual return. Then we use the residual series to calculate the covariance matrix of all the stocks. We define the sigma square is on the diagonal line. Then we know sigma S. So we know all these 3 terms and we can calculate the Sharpe ratio for each stock. Then we select the 10 stocks with the highest Sharpe ratio. Then YUXUAN will introduce how to find the weight of each stock.
I'm gonna introduce the basic theory behind our portfolio combination. After selecting the 10 stocks with the highest Sharpe ratios, we calculated the residual matrix of those 10 stocks and get the semi-deviation estimation of the residual matrix. The semi-deviation estimation can reveal the worst case performance to be expected from a risky investment. In order to get the weight of each 10 stocks, we use the risk portfolio package in R. We input our covariance matrix estimation, the mean of predicted log return, and the semi-deviation estimation of those 10 stocks into the function optimal portfolio to compute the weights of the risk-efficient portfolio. The equation of the function is shown here. Now, I'll pass to Li to show how the result of our portfolio combination.
After about steps, we get the weight of each stock and the risk efficient and minimum variance method. From the 2 plots, we can find the investment ratio of efficient method are more averaged, and the minimum portfolio only focused on more stable underliers, just like TX. If we choose minimum variance method, we will lose a lot of opportunities for profit. And we are not absolute risk-averse investors, so we choose the risk-efficient method. Under our strategy, we choose equal weight portfolio as our benchmark portfolio. Apply the investment ratio to October actual training data. Calculate the difference between daily return of our portfolio and the benchmark portfolio. We can find our portfolio's performance are better than benchmark portfolio in most trading days. At last, our portfolio October monthly return is 3.84% and the expected annual yield is 46.17%. That's all my presentation. Thank you.